Hello students, welcome back to chemistry class, and today we are going to discuss about the electrophilic substitution reactions of ethers. So the alkoxy group present in the ethers, that is alkoxy group means OR. So this alkoxy group is ortho and para directing. So it is ortho and para directing, and it activates the aromatic ring towards electrophilic substitution reaction. So in the same way as in phenols, that is how the electrophilic substitution reactions takes place in the phenols are already discussed. So in the same way, so the ethers also undergoes electrophilic substitution reactions. Before going to discuss about the electrophilic substitution reactions, let us see the resonance structures of ethers. That is, aromatic ring, that is benzene ring. To the benzene ring, one alkoxy group is attached. That is, the alkyl and aryl groups are attached through the oxygen, and this oxygen contains two lone pair of electrons. In the resonance structures, let us interchange the electrons present in the molecule. That is, the lone pair of electrons on the oxygen atom undergoes delocalization, that is, it is shifted towards the aromatic ring, and the double bonded electrons present in the benzene ring is shifted to the next carbon. It is shifted to the next carbon. So it gives the first resonating structure, that is, this carbon gets the negative charge, and there is a double bonds between the oxygen and carbon, and there is a positive charge. So this positive charge is due to the loss of electrons, that is, the lone pair of electrons are shifted towards the carbon, and the remaining two bonds are present at the same positions. And the next resonating structure, so this negative charge shifted to the next carbon, and double bonded electrons shifted to the next carbon, and it gives the second resonating structure. So it is minus, and it is double bond, and it is double bond. So it is double bond O and R, and positive charge on the oxygen. And the next resonating structure is, that is, the negative charge shifted to the next carbon, double bonded electrons to the next carbon. So it is negative, and it is double bond, and it is double bond. So it is double bond O, R, and positive charge. And finally, the original structure is arised in the next structure, that is double bond, double bond, double bond, and it is O, R, and two lone pair of electrons. So in the second structure, for example, it is 1, 2, and it is 3, and it is 4, and it is 5. So the first structure and the fifth structure are similar. The difference is the position of the double bonds. And the resonance structure, that is second one, third one, and fourth structure, has negative charge at ortho and at the para positions. That is, there is an negative charge at ortho and para positions. So that indicates the electron density is more at these positions. That is, more electron density at ortho and para positions. Therefore, the electrophile is preferably attack on these positions, resulting in ortho and para substituting product. That is, resultant products are ortho or at the para products. That is, the electrophile prefer to attack only at ortho positions as well as at the para positions, but not at the meta positions, because there is an electron cloud more only at ortho position and at para positions. Hence, the electrophile preferably attached at the ortho and para positions. So let us see the chemical reactions, that is electrophilic substitution reactions of ethers. First one, halogenation, that is the ethers reacts with the halogens. For example, let us take anisole, that is R is methyl group, very important chemical reactions, that is OCH3, so it is to be called as anisole. So when anisole reacts with the bromine, in the presence of ethanoic acid. So this ethanoic acid acts as a catalyst. So the electrophile Br plus attached at ortho and para positions. That is, it gives the mixture of ortho and para bromo anisole. First attach at the ortho position and then attach the Br, that is electrophile, at the para position. So it is Br, so it is OCH3. So this molecule is to be called as ortho, bromo, and the remaining part is anisole, and here the name of the molecule is para, bromo, and the remaining part is anisole, para, bromo, anisole. Here the major product is para product, so it is a major product and it is minor product. That is, out of 100%, 90% of the compound is para bromo anisole, because there is a less repulsion between the methoxy group and halogen Br. But in the ortho products, there is a certain repulsion between the methoxy group and halogen. Hence, this molecule is less stable. Therefore, the mixture contains the 90% of para bromo anisole and the remaining percentage is ortho bromo anisole. And next, let us see the Friedel-CRAFTS reactions. That is Friedel-CRAFTS alkylation and Friedel-CRAFTS acylation. So acylation is nothing but the compound, that is anisole, is to be treated with the acetyl chloride CH3COCl in the presence of a catalyst, that is anhydrous ALCl3. And during the alkylation reactions, so the ethers are treated with the methyl chloride CH3Cl in the presence of same catalyst, that is anhydrous ALCl3. Very important reactions and simple reaction. Just remember the reagents to be used in the alkylation and acylation. In the acylation, acetyl chloride is to be used as a reagent, and in the alkylation, methyl chloride is to be used. Let us see the chemical reactions. That is the Friedel-CRAFTS alkylation of or acylation of ethers, that is OCH3, so it is to be called as anisole. So this anisole is treated with the acetyl chloride CH3COCl. So here halogen has negative charge, carbonyl carbon has positive charge, so the electrophile is CH3CO. So this is to be called as electrophile part, and the reaction takes place in the presence of anhydrous ALCl3, acts as a catalyst. So the product is the mixture of ortho and para substituted, that is CH3. The electrophile is COCH3 So this COCH3 attached at ortho position as well as at the para positions. So it is COCH3 and the para product is, that is OCH3 and it is COCH3. So the molecules are to be named as, that is the first carbon and second carbon here 1, 2, 3 and 4. So second carbon contains one methoxy group. So it is to be represented as 2-methoxy. 2-methoxy and the remaining part is acetophenone. Acetophenone. Or it is also to be called as orthomethoxy anisole, and it is to be called as 4-methoxy acetophenone, or it is to be called as para-methoxy anisole. Here the major product is para product. It is the major product and it is minor product. That is, when anisole reacts with the acetyl chloride in the presence of anhydrous aluminum chloride and it acts as a catalyst, or it is also to be called as Lewis acid, the mixture of 2-methoxy acetophenone and 4-methoxy acetophenone is obtained. This reaction is to be called as Friedel-CRAFTS acylation reaction. And let us see the alkylation reaction. That is anisole OCH3. So it is anisole. So this anisole reacts with the alkyl chloride, that is CH3Cl, in the presence of a catalyst, that is anhydrous AlCl3. So it gives the product, that is OCH3, and the electrophile is CH3. CH3 carbon has plus and halogen has minus charge. So this hydrogen and this hydrogen is to be eliminated along with the Cl. It gives 2HCl. That is, the reaction takes place in the presence of 2 moles of anisole and 2 moles of methyl chloride. So it gives the product, that is, one is ortho product CH3 attached at ortho position and CH3 to be attached at para position. So it is to be called as 2-methoxy and this part is to be called as toluene, 2-methoxy toluene, and it is to be called as 4-methoxy toluene. So it is minor product and it is major product. That is, when anisole reacts with the methyl chloride in the presence of anhydrous aluminum chloride as a catalyst, or the reaction takes place in the presence of CS2, the mixture of 2-methoxy toluene and 4-methoxy toluene is obtained. So this reaction is to be called as Friedel-CRAFTS alkylation reaction. That is, alkyl electrophile attached at ortho and at the para positions. Next reaction, that is nitration of anisole. The anisole OCH3. So it is anisole. So this anisole undergoes nitration in the presence of nitrating mixture. that is the nitrating mixture is HNO3 in the presence of H2SO4. So it is to be called as nitrating mixture. So the electrophile is NO2 group. So it gives the mixture of ortho and para substituted product, that is OCH3, and it is NO2 plus the para product, that is OCH3, and it is NO2. So the electrophile attached at ortho position and at the para position. So it is to be called as 2-nitroanisole, and it is to be called as 4-nitroanisole. And here also the major product is para product and it is minor product. That is, when anisole reacts with the nitrating mixture, that is the mixture of concentrated sulfuric acid and nitric acid, to yield a mixture of ortho and para nitroanisole. Mixture of ortho and para nitroanisole. So these are the electrophilic substitution reactions of ethers, especially for the anisole. And let us see how these alcohols are commercially important. That is, how this methanol and ethanol are commercially important. First, let us discuss about the methanol. That is, this methanol is generally prepared by a catalytic hydrogenation of carbon monoxide. Catalytic hydrogenation, that is carbon monoxide in the presence of hydrogen, and the catalyst used is COO and ZNO and Cr2O3. So it is to be called as a catalyst. And at high pressure, that is around 200 atmospheric pressure, and the temperature is 573 Kelvin. So at this temperature, the methanol is to be prepared, CH3OH. Here the number of moles of hydrogen required is 2 moles. And this methanol is also called as wood spirit. It is to be called as wood spirit, because earlier it was prepared by destructive distillation of wood. That is, this methanol is to be generally distillated from the wood. Hence it is to be called as wood spirit. And let us see the properties of methanol. That is, the methanol is colorless liquid. It is a colorless liquid, and the boiling point is 337 Kelvin. The boiling point is 337 Kelvin. And the most important point, this methanol is highly poisonous in nature. It is poisonous in nature. So the ignition of even small quantities of methanol can cause blindness, and large quantities causes even death. Methanol has very poisonous in nature, and ignition of even small quantities of methanol can causes blindness, and in the large quantities it causes death. And let us see the uses of methanol. That is, uses. What are the uses of methanol? Generally, this methanol is to be used as a solvent. It is to be used as solvent in paints and varnishes. So this methanol is generally to be used as a solvent for paints and varnishes, and also it is to be used as a denaturant for ethyl alcohol, denaturant that is the loss of naturality for the ethanols, that is denaturant for ethanol or ethyl alcohol. And it is to be used in the manufacture of formaldehyde. This methanol is generally used in the manufacture of formaldehydes, and which in turn is used as a preservative for biological specimen and for making synthetic resins. This formaldehyde generally used to store the or prevent the biological specimens and for making the synthetic resins. So these are the important properties and uses of methanol. Let us see the importance of ethanol, that is ethanol. So this ethanol in the commercially, it is to be prepared on the large scale by hydration of ethene as discussed in the preparation of alcohols and fermentation of carbohydrates. Fermentation means, that is, it is the oldest method for making ethanol from sugars. That is, the sugar is C12H22 and it is O11. So it is to be called as sugar. So the sugar present in the molasses and sugar cane are converted into glucose and fructose. That is, it is to be converted by using an enzyme that is to be called as invertase. So this sugar to be converted into glucose, that is the glucose is C6H12O6 and fructose, so this C6H12O6. So both glucose and fructose has similar formula, but it has different structures. That structures are to be studied in the biomolecules chapter. That is, the sugars present in the molasses and sugar cane are to be converted into glucose and fructose in the presence of an enzyme invertase. Then glucose and fructose get converted into ethanol and carbon dioxide by undergoing fermentation in the presence of an enzyme. That is, the obtained glucose is to be converted into ethanol by using an enzyme is to be called as gymase. That is, glucose is C6H12O6. So it is glucose and fructose. Both the glucose and fructose gets converted into ethanol, that is C2H5OH, and it is 2 moles, and it releases carbon dioxide gas, and the reaction takes place, that is fermentation process takes place in the presence of an enzyme. It is to be called as gymase, and this gymase is generally found in the yeast, and fermentation process takes place in the anaerobic conditions. That is, the reaction takes place in the absence of air. That is, the reaction takes place in the anaerobic conditions. Anaerobic means there is no air. And if fermentation process takes place in the presence of air, then oxygen of air oxidizes ethanol to ethanoic acid. That is, if the reaction takes place in the presence of air, this ethanol to be converted into ethanoic acid, CH3COOH. That is, the ethanol undergoes oxidation. Hence, the reaction is to be takes place at anaerobic conditions. And the fermentation of carbohydrates yields ethanol containing water, and this solution on fractional distillation forms an azeotrope containing 95% of ethanol and 5% of water. That is 95% of ethanol and 5% of water. Thus, by simple fractional distillation, we can get at the most a solution containing 95% ethanol. And this 95% ethanol is to be called as rectified spirit. Rectified spirit. So in the examination they may ask what is rectified spirit. So rectified spirit is the 95% of ethanol. The 95% ethanol is to be called as rectified spirit. And let us see the properties. That is, this ethanol is also a colorless liquid and it boils at 351 Kelvin. 351 Kelvin. That is, boiling point is 351 Kelvin. And let us see the uses of this ethanol. And like methanol, this ethanol is also used as a solvent in the paint industries, and it is used as antifreeze. That is, it is to be used as antifreeze, and it is used in the manufacture of dyes, synthetic drugs and detergents. And this ethanol used for industrial purposes is made unfit for drinking by the addition of 5 to 10% of methanol. That is, generally ethanol is not poisonous, only methanol is poisonous. So in order to make unfit for the drinking of ethyl alcohol, the 5% to 10% of methanol is to be added in order to prevent the misuse of ethanol. And this ethanol is denaturated by methanol, and a little of pyridine and acetone is also to be added. So this is to be called as methylated spirit. That is, methylated spirit. So methylated spirit means methylated spirit contains ethanol plus methanol plus pyridine plus acetone. So this mixture is to be called as methylated spirit.